Okay, this should look familiar to you. I'm using the same equipment that I use in the classroom. This is solving quadratics by factoring day 1. Okay, the idea behind this, okay, so I'm going to introduce the idea real quick. I need to find this great piece of paper. If I have something times something else, and I tell you that their product is equal to 0, what do you know about one of these? In order to get a product to equal 0, one of these has to be 0, right? So if this were 0 and this were 5, you know the product is 0. The idea is, if I have a product equaling 0, I know one of them has to be a 0, okay? If I had something times something equals, I don't know, 42, it could be 6 times 7, it could be 2 times 21, it could be 3 times 14. The problem is, if this is not 0, I don't have any guarantees what these are. Okay? So these problems are based on this idea that I have something times something else equaling 0. That means one of these have to be 0, or either one can be 0. And what we're going to do is set each factor equal to 0. What does that look like? It looks like this. X plus 8 equal to 0. X plus 6 equal to 0. And then we're just going to solve them separately. So subtract 8. So I get x equals negative 8. Subtract 6. So I get x equals negative 6. That's it. Okay, so what does this mean? That means this value makes this statement true. I plug in negative 8. That'd be negative 8 plus 8, which would be 0. 0 times, and then I plug in negative 8 over here. Negative 8 plus 6 is negative 2. 0 times negative 2 is 0. So negative 8 makes this a true statement. If I plug in negative 6, negative 6 plus 8 is positive 2. Negative 6 plus 6 is 0. Positive 2 times 0 is still 0. So both values make it equal, or make the original equation true. So those are my solutions. Okay, so number 2 looks the same way, so you would do it the same way. Number 3 looks a little different because the factors look a little different, but still, this is still a factor. 6n is a factor, even though it doesn't look like the other ones. So it's 6n equal to 0, and we do the same thing with 5n minus 7. 5n minus 7 equal to 0. And we solve them separately. Well, here, we could divide that by 6, n equals 0. Or if you simply knew that n equals 0, that's fine. Right? 6 is never equal to 0, but the n can be. Here, we add 7 to both sides. We get 5n equals 7, divide by 5, n equals 7/5. If you give me decimal answer for these, that's perfectly fine. This will be like 1.4, I think. Okay? Alright, let's do a couple of these, I guess. No, they all look about the same. Alright, I'll do number 5 real quick. The 6 here, 6 doesn't have a variable. 6 will never be 0 on its own, so we can ignore that. The other ones have a variable in them, so they can be set equal to 0 and solved. Subtract 2, 3p equals negative 2, so p, divide by 3, so p equals negative 2/3, or negative 0.67. Either one is fine. So that's it. That is factoring day 1.